Hi everyone, it's Mr. Zabo, and we are going to start talking about perpendicular bisectors and the circumcenter today. And what we just finished up with was the median with the centroid. This is a different center of a circle. It's not necessarily at the same location, although it can be at the same location as the centroid. So if you recall what the centroid is, that's the point of concurrency where the three medians of a triangle intersect. Now we're talking about the point of concurrency where the three perpendicular bisectors intersect. There are one really important key component of the circumcenter, and that's the fact that it is located so that it is equidistant to the vertex of each vertex of the triangle. Slightly different than the centroid. Centroid was 2/3 of the distance from each vertex, but those 2/3 could have been different. Okay, so the medians don't all have the same length. Here, this is always equidistant to every vertex. Therefore, we get the second bullet point here. It's the center of a circle that circumscribes this triangle. What does that mean? If you look at our examples down here, I've kind of started to sketch what that means. Okay, so if G is the circumcenter for all of these triangles, in an acute triangle, it is located inside the interior of your triangle. In a right triangle, it is located at the midpoint of the hypotenuse. In an obtuse triangle, it's actually located outside in the exterior of your triangle. And you can see a couple of things here. The circle, by circumscribed, it means the center will be at the circumcenter, but then its circle will be going through all three vertices. Center of the circle, all three vertices are on the circle. Center of the circle, even though it's in the exterior, all three vertices are on the circle. Now, what I want you guys to do is see if you can kind of sketch what this is going to look like. And so I'll do one with you. Okay, so if I have this triangle, and we'll call it a right triangle, and if I wanted to sketch where the circumcenter was, with showing the appropriate tick marks, what I want to do is first rough sketch, if I don't have something to, like a compass and a straight edge, rough sketch a midpoint here, rough sketch the midpoint on segment MO, mark it, and rough sketch of the midpoint of segment OM, about here, and mark it. So that I've now shown appropriate tick marks for the bisector or the midpoints. Now I want to show the appropriate perpendicular aspect of this. So I want to kind of sketch in, and I usually use dash lines to show it, all of the perpendicular bisectors. Now, all I've done is sketch something in. To show that they're perpendicular, I have to physically put these marks in at the midpoints. That is now showing perpendicular bisectors. So in some problems you might be told that you have a circumcenter. In others you might just be given a diagram like this. And from that diagram you have to conclude that it is the perpendicular bisector and therefore equidistant to all three vertices. And so in this case, if I sketched here to here, it happens to be a median, but it's also going to be congruent to these two segments here and here because those are equidistant. Okay. Press pause and see if you can sketch where the circumcenter would be with triangle GHI. Okay, hopefully you identified it in the exterior out here beyond segment GH and marked your congruent segments here, congruent segments here, congruent segments here, plus your three perpendicular segments. Now, we're going to take it another step, and again, here I could have drawn in segments from here to here and say, hey, those are all equidistant. And that's really one of the big applications of this algebraically. So if I said that you had circle O, you had O as the circumcenter, I'm telling you it's the circumcenter. Your straight up conclusion from that is that segment OX is congruent to segment OY or equidistant and segment OZ. Those all are congruent. Okay. So from that, I'm going to now start labeling other things I know. I know that ZY is 30, but A is marked as the midpoint. Therefore, this must be a length of 15 and 15. And since OA, this piece here, is 8, and I know this is perpendicular, I want to find OX, but we've already talked about this part. OX has to be equal to OY and OZ because it is the circumcenter. Well, I have two right triangles here. I can use Pythagorean theorem or our Pythagorean triples to state that OY, OZ, OX, all of them are going to be, well, we have 8, 15, they must be 17. So in this case, I can conclude that OX has a length of 17. Algebraic example here, but in this case, we haven't been told in the directions here that we have a circumcenter. What we've been told is that it's a circumcenter using all the marks in here. The fact that D is a midpoint and DG is perpendicular makes it a perpendicular bisector. Perpendicular bisector. Perpendicular bisector. All three perpendicular bisectors intersect here at G. Since these are all perpendicular bisectors that intersect at G, G becomes the circumcenter. And that allows us to conclude that BG is congruent to AG is congruent to CG. Or in this case, that C or GB is 15 and CG is also 15. Okay. The other one that's not too hard here is CB. Okay, we have these marked congruent, that's 12. Well, this must be 12, so CB must be 24. Okay. For AE, we have to take a little bit of a leap of faith here, and so I'm going to tell you, assume in this case, and you can't always, but I'm giving you permission to in this problem, assume that A, G, and E are all collinear. If we make that assumption, we should be able to, from here, identify what the length of AE is. Go ahead, press pause, and write that down. Okay, so now we know that BG is 15, we have BE is 12, we've got a right triangle, 3, 4, 5 is the same as 9, 12, 15, EG must be 9, and again, making the assumption, which we can't always do, but I gave you the permission to here, that AG and E are all collinear, then AE, under those criteria, is equal to 24. All right, for number 3 here, we're going to start talking a little bit different about some coordinate geometry. And we're going to go back and start talking about the equations of lines, in this case, the equations of perpendicular bisectors. So to find the coordinates of a circumcenter, we're going to have to solve a system of equations, those equations being the perpendicular bisectors. See if you can come up with 2 equations for perpendicular bisectors given these coordinates for your triangle. The first one that I came up with, I took A and C and found the midpoint. 1 plus 5 is 6 over 2 is 3, 3 plus 3 is 6 over 2 is 3, so there's my midpoint. That's going to be the point, and then I need the slope of my perpendicular bisector. So I need to find the slope of my original segment, and the perpendicular is the opposite reciprocal. But the slope of AE is 0. Then I must have an undefined slope for my perpendicular bisector, making it a vertical line. X equals is the equation of a vertical line, and x has to equal 3 since that's the x coordinate. So you can come up with a second equation. So in this case, I used segment BC. You could have used, I used AE first, or AE, it was AC first. I'm not sure how that happened. And then I did BC. You could have done AC. I used BC, so that's 4, 1 is my midpoint. The slope of BC is 2. The slope of the perpendicular bisector is -1/2. I plug in my ordered pair for the midpoint. I can't use B or C. They're not on the perpendicular bisector. The midpoint is, so I get 1 equals -1/2 times 4 plus B. B is 3. From here, I solve the system to find the coordinates of my centroid. Accomplishing that, plug 3 in. X is definitely 3. Substitute in 3. I get Y is 3/2. The centroid is at 3, 3/2. Now, I want to find the area of that circle. Well, the area of a circle is pi r squared. Now I need the radius. Well, the radius is going to be the distance from the centroid to any vertex. That's a distance formula problem. Go ahead and see if you can come up with the distance of the radius. So hopefully we found the radius to be 2.5. Put that into our formula, and we've got pi times 2.5 squared, 6.25 pi units squared. Again, now I know the radius, I know the center, you can come up with the equation of that circle. With a center at 3/3 and a radius of 2.5, this for our equation of our circle, because remember it's x minus h squared plus y minus k squared equals r squared, not equals the radius.